Okay, this time we're going to discuss something called the call stack. The call stack is the mechanism by which localness or locality of variables is enforced. Now, if you have a program with no functions in it, like this one, a good way to think of this is this part of the program is called the main routine. The main routine for the program is outside of any function. Things in the main routine are in the global namespace. It is the home base of your program. Now, whenever a function is called, and actually here, or whenever a function is called, what happens? Let's look at what happens. In this main routine, the print function is called. So there is a special area of memory called the stack. And what happens is the print function gets a little box, which is called a stack frame or an activation record, and that is put on the stack. Then what happens is print's local variables and interior mechanism go to work. So what's going to happen? Print is going to take hello and put it to standard output. That is print's side effect. And then once print does that, it's all over. Print is removed, its activation record is removed from the call stack and never seen again. So, when you call a function, you put its activation record onto the stack. And what's interesting about stacks is stacks behave like stacks of books. The first thing that goes on is the last thing that comes off. So what we'll do is illustrate this with a cascade of several functions. Let's make a couple of functions here, and just very simple ones. We'll use our old friends square and cube. All right, now return x times x and cube. And we'll use cube. We'll call square from cube because that's what will make things interesting here. Okay, so here we have it. And I'm just going to say print cube of 5. Now we all know what this program is going to do. It's going to print the number 125. But how does it do that? Well, the first thing that happens is it encounters a function right on line 1 in the main routine. Okay, and Python says, okay, put print on the stack. So print is now on the stack. And inside of print is cube of 5. So print is stuck. It doesn't know what to do. But one thing about an activation record or a stack frame is it knows exactly where it left off if it hands off to something else. So print is now going to hand off to cube. Cube is going to go on top of print. Okay, so cube goes on top of print. So we have something that looks like this. I'll make a comment down here. Here's print at the very bottom. And when it sees cube of 5, when it sees cube, of 5, it's completely flustered. So what's going to happen is on top of this is cube now is going to have an activation record. That value 5 is passed to x. So cube has a symbol table, x, pointing at the value 5. Now the reason we can call print in here is print is part of the global infrastructure of Python, so it's visible. The reason we can call cube is these two function names are they are global variables because they are variables. Function definition is a form of assignment. They are variables and they are directly in the program, so they're in the global namespace. They can be seen. Now inside of cube, This X pointing at 5 is private. Okay, and I'm going to change this to this because I want this. I overstepped here. I'm going to fix this. I want to do r times square of X. Because I want to see all these functions go into action. So I get inside of here, and cube starts working. And it's going to return 5 times square of 5. And it's going to say, uh-oh, I'm stuck right here. I need to stop. So inside of this top stack frame belonging to cube, he's stuck. He has to pass off the square, and hopefully square or somebody down the rabbit hole is going to help him out. So I'm going to go ahead and stick this on top. Now square is on top. Okay, square is now controlling the program. So what does square have? Square has an X, and again the value of 5 is passed in. Why? Because here X is 5, and we're going X times square of X. That 5 is passed up here to square. Okay, square now sees X is 5. Now, a funny thing about a return statement is it's kind of backwards, like assignment is. The first thing that will happen is this thing will be evaluated. So X star X gets evaluated, and its value is 25. Then return 25. What does that do? 2 things are going to happen. 1, the value 25 is going to come down here. So I'm going to get rid of this square here. And 25 is substituted in. And the other thing that happens is smash! That stack frame is now gone. Now cube sees 5 times 25 and it wants to return that. And it can't. Because 5 times 25 is a very nice sociable thing. It evaluates to 125. So I can now skedaddle out of here. And what happens? This thing returns 125. Bam! Destroyed. And then what happens down here? Let me get that comment mark back. Come on. All right, let's get it in there. Is this becomes the 125 that got passed back. All right. So always the return gets sent back to whomever called it exactly, precisely where it left off when it was called. That's how this works. So now it says print of 125. What happens now? 125 gets put to the screen. And then this gets destroyed. And once there's no more stack, your program's execution terminates. Okay? So when the main routine runs out of code, that's the end of the road.